Okay, so this lesson was on the resistance required practical, and we just began with a bit of a joke about this is Ohm's dating profile. So yeah, it was just some information I wanted to get across to you. And basically, he discovered the relationship between potential difference and current through a resistor, and he got his own statue, which is very, very cool and something that we'd all love, our own statue. So this took 2 lessons. The first part of the lesson was thinking about how the current which flows through our phones is determined, because if you remember a few years ago, some of the Samsungs used to set on fire. So you need to be able to draw a circuit diagram used in the required practical to prove Ohm's law. You need to be able to analyse the results of Ohm's law and then answer a 6-mark question on the application of Ohm's law. So this is his resistance equation. We spoke about it in the previous lesson, and there's a practical you had to do. So in the folder for this lesson, you'll find the required practical information. Just highlight it, and what we did was we highlighted it in 3 colours. So the first highlight we used was to write how to set up the experiment, so you could do that now. Set up including like how to add the ammeters and the voltmeters. The second highlight was then for anything that was a measurement. So in this practical, you have to measure the current and the potential difference. Okay. And then the third highlight was anything that was a calculation. So if you go through the method now, or if you print off the sheet or come and get one from me, you can then highlight the different colours. Just there were some hazards as well, that the wires can get hot and burn the skin, so a way to combat that in the practical was keeping the current low and turning off the power supply between the readings. This was basically the method. Power supply measures current and potential difference. And then here there was a wire, and what we did was it was attached to a ruler, and we changed the length of the wire in the circuit, increasing it, okay, and measured how the current and potential difference changed. So this was our table of results, okay? So we changed the length and we measured the potential difference and current. Then at the end we used Ohm's law to calculate the resistance. And what we found out from the graph was, basically, I haven't drawn this on here, but if you draw a graph against length against resistance, the resistance gets higher the longer the wire. And from the home learning from the previous lesson, you should know that the longer the length of wire, the more fixed irons are in the way of the current flow. So as the current is flowing through the wire, if you increase the length of the wire, there are more fixed irons. So as the electrons travel through the wire, okay, they hit more of those big irons, so there are more collisions per second. And if there's more collisions per second, there's more resistance, okay? So the longer the wire, the more resistance, because there's more fixed irons for the delocalized electrons to bang into, and so there's more collisions. We also talked about how to improve our results. So you can use a jockey instead of crocodile clips. We use crocodile clips, but they're quite wide. A jockey is like a thin point if you look here. So if you use a jockey, you can get a much better or smaller area on the wire, so you get a more precise reading of your length. So the resolution is higher and the results would be more accurate. Okay. We then did the second part of practical, which is where we had some resistors in series and parallel. So we had 2 10-ohm resistors in series like this and next to each other, and we measured the voltage and the current. And then we had them in parallel where they're on top of each other like this, and again measuring the current and the potential difference. What we found in this case is when you have these were two 10-ohm resistors. So this was 10 ohms and this was 10 ohms. And what we found was that the current and the overall resistance for this circuit was 20 ohms. Okay, 20 ohms. What we found when we put them in parallel and calculated it was the resistance was 5 ohms. So in parallel, what we found out for this method was in parallel, the resistance is lower than in series. And in the next lesson, which is on series and parallel, we talked about why that was. So for the second part of this practical, those were the results. In parallel, the resistance is lower than in series. So again, we highlighted the method when we did it. We did the setup in one colour, and then we did what results we were going to take in another colour, and then the calculation in the third colour. So if you can do that, and then I think it's questions 7, 8 and 9 are just talking about the fact that the resistance is lower in parallel than in series. And what we finally just discussed was just about the phones, that the phones set on fire because there must have been a problem with the circuit, and so the current was too high. So there was a huge number of collisions with the fixed irons in the wire, which then heated the wires up and they set on fire. Okay, right. There is an exam question in the folder too, so you can have a go at the exam question, mark it with a mark scheme. Anything you're still not sure about, ask me.